So a main problem in our initial results from our word count script is that we didn't account for things like punctuation and capitalization and things like that. So there's fancy ways to deal with that problem in text processing, but we're going to use a simple way for now, just using something called regular expressions in Python. So let's show how that works and actually run it and see it in action. All right, so if you recall, we had a first crack at counting the number of times each word occurred in our book before, but the results weren't that great. We had each individual word that had different capitalization or punctuation surrounding it being counted as words of their own. And that's not what we want. We want each word to be counted only once, so no matter how it's capitalized or what punctuation might surround it or various variants of the word, we don't want to have duplicate words showing up in there. Now, there are toolkits you can get for Python like NLTK, the Natural Language Toolkit, that have fancy, very complicated ways of normalizing text data like this and automatically figuring out what words are the same. But we can sort of do a more simplistic attack at it and use a regular expression in Python in order to convert words into some common format and strip out all of the extra punctuation that we don't care about. So not really a Spark specific thing, but it's a very useful trick to have in your back pocket, especially when you're doing text analysis. So let's take a look at the code and see how that works. Okay, let's try and improve upon our word count script. So in the resources for this lecture, you should find a word count better Python script. So hit pause and go download that and save it into your Spark course folder. And as usual, let's double click it and take a look. All right, so you see this is a little bit more complicated than what we had before. A lot of the same stuff, but the main difference is that when we're calling flatmap, instead of just using a lambda function that calls split to just split up each word in the line based on whitespace alone, we're going to pass in an actual function here called normalize words. And normalize words does something a little bit fancy, so let's talk about that shortly. Basically, we're setting up a regular expression, and that's what RE stands for. You see that we added import RE to the top of the script here. And regular expressions, if you're not familiar with them, are sort of a language of their own for text processing. And it allows you to write little strings that define how to split up a string into other values or transform it. So it's sort of a very shorthand way of doing some text processing. And in our case, we're going to call re.compile, and this is the magical string that means I want you to break up this text based on words. And the W plus, capital W plus, indicates break it up based on words, and the regular expression engine knows on its own how to do that and strip out punctuation and other things that aren't really part of words automatically. We'll tell it that this may have Unicode information in it, and then we will split it up, based on what the regular expression identifies as individual words, and transform those all to lowercase. So the regular expression will take care of breaking up the words, taking account of all the punctuation, and then we're going to force that to be lowercase so that we don't get different results for different types of capitalization on each word. And that should produce better results, so let's give it a try. Again, it's not really a Spark specific thing, but it's just a good tool to have when you're doing this sort of analysis. So we're going to run spark submit word count better.py. Let's see what it does. And there we go. That looks a lot prettier, doesn't it? So we don't have a whole lot of weird capitalization and punctuation going on. This looks like much more usable results. So clicks actually shows up 3 times, the word out 161 times, and so on and so forth. Workaholic only once. I guess that's a good thing. And you can scroll through this and see, you can eyeball what words tend to be popular, but the last thing we need to do is make this more usable by actually sorting it by what words are the most popular or the least popular. And the main problem there is that if we were to just sort this list as is, it would sort it based on the word, right? What we really want to sort on is the count that's after it. So we're going to have to shuffle these results around a little bit before we can sort them the way we want. And let's go over how to do that in our next lecture. All right, things are looking better now. We've accounted for all the capitalization and punctuation weirdness for the most part in our data there, and we were getting some results that are starting to look interesting. But to really be able to interpret them better, we need to be able to sort them the way we want so that we can see the words that are least frequently used and most frequently used more easily. So let's do that next.